The kitchen clock is a silent architect of skeletal strength. While we prioritize nutrients like calcium, the physical durability of our bones is heavily dictated by the timing of our meals. A massive study of nearly 1 million people has clarified the link between meal schedules and the risk of future bone fractures. We'll look at the data behind these timing patterns, the cellular mechanics involved, and the daily protocol that helps maintain bone density. Data from Nara Medical University in Japan shows that specific dietary habits correlate with bone vulnerability. Participants who skip breakfast more than 3 times a week show an 18% higher risk of experiencing a major fracture compared to those with regular morning meals. Eating a late dinner, defined as a meal within 2 hours of sleep, is associated with an 8% increase in risk. For individuals who combine both habits, the likelihood of a major fracture climbs to 23%. This risk isn't distributed evenly across the skeleton. The study found these timing-related vulnerabilities specifically in the hip, the spine, and the humerus of the upper arm. Missing a morning meal seems disconnected from a broken hip decades later, but the link lies in how our internal clocks manage bone maintenance. To understand the connection, we have to view the skeleton as a living tissue that is constantly dissolving and rebuilding itself at the cellular level. The cells responsible for this process, called osteoblasts, do not work at random. They follow a schedule dictated by their own internal biological timers, known as clock genes. These cells rely on external cues. A consistent breakfast is a primary signal, synchronizing peripheral bone clocks with the brain to ensure bone is replaced efficiently. But an irregular schedule desynchronizes this system. Missing this morning signal interrupts the rebuilding process. This makes skipping breakfast a metabolic timing error. It creates a rhythmic disruption in bone maintenance that isn't solved by simply consuming the same amount of calories later in the day. The disruption continues in the evening. The researchers categorized a late dinner as eating within 2 hours of bedtime at least 3 times a week. Digesting food late at night triggers a spike in cortisol and increases oxidative stress. This occurs at the exact moment the body needs a low-stress state to carry out cellular repair and bone deposition. The data reveals a pattern. The hip and spine are sensitive to meal timing stressors, but fractures of the distal forearm showed no link. Forearm breaks result from active falls in youth, whereas hip fractures stem from metabolic bone thinning over time. The study also noted that skipping breakfast and eating late dinners tend to cluster with other risks, such as smoking, insufficient sleep, and physical inactivity. The primary danger is the compounding effect of these behaviors, which creates a loop of physiological stress that slowly degrades the structural integrity of the skeleton. This evidence redefines osteoporosis as a preventable lifestyle disease. By addressing meal timing, we move bone health out of the category of inevitable aging and into the category of proactive maintenance. The first step in the protocol is to eat breakfast at least 5 days a week. This provides the necessary signal to keep the internal clocks of your bone cells synchronized. The second step is to finish dinner at least 2 hours before sleeping. This reduces nocturnal cortisol and oxidative stress, protecting the environment your body needs for bone repair. When this timing is paired with brisk walking and regular sleep, it creates a protective effect that helps maintain bone mineral density. By aligning when we eat with our internal biological rhythms, we provide the cellular instructions necessary to deliberately fortify the physical foundation of our bodies.